Current-limiting overcurrent protective devices and series-rated circuit breakers serve different purposes in electrical systems. As defined in NEC 240.2, current-limiting overcurrent protected devices are designed to interrupt fault currents within less than half a cycle, which is 10 milliseconds at 60 Hz. By interrupting the fault current quickly, current-limiting overcurrent protective devices limit the peak fault current and prevent it from reaching its full magnitude, reducing the potential for equipment damage and arcing. NEC 240.86 requires series rating for circuit breakers installed on circuits with available fault currents exceeding the marked interrupting rating of the circuit breaker. Series rating ensures that the circuit breaker can safely interrupt the maximum available fault current on the system. It involves coordinating the interrupting ratings of multiple circuit breakers in series to achieve the required interrupting capacity. An interpretation that all systems must be fully or series rated, regardless of let-through fault current values, is overly conservative and goes beyond the requirements of NEC 240.86. The purpose of current-limiting overcurrent protective devices is to limit the peak fault current, while series rating ensures that the downstream circuit breakers can safely interrupt the available fault current. The requirement for series rating only applies when the available fault current exceeds the marked interrupting rating of the downstream circuit breakers. If the let-through fault current after the main disconnect is less than the marked interrupting rating of the downstream circuit breakers, series rating is not required. In this case, current-limiting overcurrent protective devices can be used to further limit the peak fault current and provide additional protection to downstream equipment. Current-limiting overcurrent protective devices serve the purpose of limiting peak fault current, while series rating ensures that the circuit breakers can safely interrupt the maximum available fault current. For proper application, the available fault current and the marked interrupting ratings of the circuit breakers should be considered to determine if series rating is required. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Understanding the NEC is crucial for ensuring the safe and reliable operation of electrical systems. Article 240 of the NEC focuses on overcurrent protection, which is a critical aspect of electrical safety. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from excessive current that can cause overheating, fire, and equipment damage. The NEC provides detailed requirements for the selection, installation, and coordination of overcurrent protection devices. Current-limiting overcurrent protective devices are a specific type of overcurrent protection device that are designed to rapidly interrupt fault currents. These devices are capable of limiting the magnitude and duration of fault currents, thereby reducing the potential for damage to electrical equipment. The NEC defines a current-limiting overcurrent protective device as a device that, when interrupting current within its current-limiting range, reduces the current flowing in the faulted circuit to a magnitude substantially less than that which would be attained in the same circuit if the device were replaced with a solid conductor having comparable impedance. This definition highlights the key characteristic of current-limiting overcurrent protective devices, which is their ability to limit the peak fault current. The ability of a current-limiting overcurrent protective device to limit the peak fault current is due to its rapid response time. These devices are designed to interrupt fault currents within a fraction of a cycle, typically less than half a cycle or 10 milliseconds. This rapid response time is achieved through the use of advanced technologies, such as fast-acting fuses and circuit breakers with electronic trip units. The rapid interruption of fault currents by current-limiting overcurrent protective devices has several benefits. Firstly, it reduces the thermal and mechanical stresses on electrical equipment, thereby extending its lifespan. Secondly, it minimizes the potential for arc flash hazards, which are a major safety concern in electrical systems. Thirdly, it improves the overall reliability and safety of the electrical system. Series rating is a method of coordinating the interrupting ratings of multiple circuit breakers in series to achieve the required interrupting capacity. The interrupting rating of a circuit breaker is the maximum fault current that the circuit breaker can safely interrupt without being damaged. In many electrical systems, the available fault current at the point of installation of a circuit breaker may exceed its interrupting rating. In such cases, series rating can be used to ensure that the circuit breaker can safely interrupt the maximum available fault current. NEC 240.86 provides the requirements for series rating of circuit breakers. This section requires that the series combination of circuit breakers be tested and labeled as a series-rated combination. The testing must be performed by a qualified testing laboratory and must demonstrate that the series combination can safely interrupt the maximum available fault current. The labeling must clearly indicate the series rating and the specific circuit breakers that are included in the series combination. The series rating of a combination of circuit breakers is typically lower than the individual interrupting ratings of the circuit breakers. This is because the upstream circuit breaker in the series combination may limit the fault current that flows through the downstream circuit breaker. The amount of current limiting provided by the upstream circuit breaker depends on its characteristics and the magnitude of the fault current. When applying series rating, it is important to consider the let-through current of the upstream circuit breaker. The let-through current is the amount of fault current that the upstream circuit breaker allows to flow through to the downstream circuit breaker. The downstream circuit breaker must have an interrupting rating that is greater than or equal to the let-through current of the upstream circuit breaker. The interpretation that all systems must be fully or series rated, regardless of let-through fault current values, is overly conservative and goes beyond the requirements of NEC 240.86. The NEC only requires series rating when the available fault current exceeds the interrupting rating of the downstream circuit breaker. If the let-through fault current after the main disconnect is less than the interrupting rating of the downstream circuit breakers, series rating is not required. In this case, current limiting overcurrent protective devices can be used to further limit the peak fault current and provide additional protection to downstream equipment. The selection of overcurrent protection devices should be based on a careful analysis of the electrical system, including the available fault current, the interrupting ratings of the circuit breakers, and the characteristics of the load. The NEC provides detailed guidance on how to perform this analysis and select the appropriate overcurrent protection devices. In addition to the NEC, there are other standards and guidelines that may be applicable to the selection and application of overcurrent protection devices. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. It is important to consult these standards and guidelines to ensure that the overcurrent protection devices are properly applied. The coordination of overcurrent protection devices is another important aspect of electrical system design. Coordination ensures that the overcurrent protection devices operate in a manner that minimizes the impact of faults on the electrical system. The goal of coordination is to isolate the faulted circuit as quickly as possible while minimizing the disruption to other circuits. The NEC provides guidance on how to coordinate overcurrent protection devices. The basic principle of coordination is to ensure that the upstream overcurrent protection device has a longer time current characteristic than the downstream overcurrent protection device. This means that the upstream device will only trip if the fault current is sustained for a longer period of time. This allows the downstream device to clear the fault before the upstream device trips, thereby minimizing the disruption to other circuits. There are several methods that can be used to achieve coordination of overcurrent protection devices. These include time current curves, selective coordination, and zone-selective interlocking. Time current curves are graphical representations of the time it takes for an overcurrent protection device to trip at different levels of fault current. Selective coordination is a method of coordination that ensures that only the overcurrent protection device closest to the fault will trip. Zone-selective interlocking is a method of coordination that uses communication between overcurrent protection devices to isolate the faulted circuit. The maintenance and testing of overcurrent protection devices are essential for ensuring their proper operation. Overcurrent protection devices should be inspected and tested regularly to verify that they are functioning correctly. The NEC provides guidance on the maintenance and testing of overcurrent protection devices. The inspection should include a visual examination of the overcurrent protection device to check for any signs of damage or deterioration. The testing should include a verification of the interrupting rating of the overcurrent protection device. The testing should also include a verification of the time current characteristic of the overcurrent protection device. The results of the inspection and testing should be documented, and any deficiencies should be corrected promptly. In summary, current-limiting overcurrent protective devices and series-rated circuit breakers are important components of electrical systems that provide overcurrent protection. Current-limiting overcurrent protective devices are designed to rapidly interrupt fault currents and limit the peak fault current. Series-rated circuit breakers are used to coordinate the interrupting ratings of multiple circuit breakers in series to achieve the required interrupting capacity. The selection, application, and coordination of overcurrent protection devices should be based on a careful analysis of the electrical system and in accordance with the NEC and other applicable standards and guidelines. The maintenance and testing of overcurrent protection devices are essential for ensuring their proper operation. By following these guidelines, it is possible to ensure the safe and reliable operation of electrical systems. Let's delve a bit deeper into the specifics of current-limiting overcurrent protective devices, or CLOPs, and series-rated circuit breakers, expanding on their individual characteristics and how they interact within an electrical system. Current-limiting overcurrent protective devices, as we've established, are designed to interrupt fault currents incredibly quickly, typically within that half-cycle time frame. This rapid interruption is achieved through various design features. Some current-limiting fuses utilize a special filler material, such as quartz sand, that helps to rapidly quench the arc that forms when the fuse element melts. This rapid quenching action limits the duration of the arc and the amount of energy released into the system. Current-limiting circuit breakers often employ sophisticated electronic trip units that can detect fault currents and initiate the trip within milliseconds. These trip units may use current transformers to sense the fault current and microprocessors to analyze the signal and determine when to trip the breaker. The ability of a CLOP to limit the peak fault current has several significant benefits. Firstly, it reduces the thermal stress on conductors and other electrical equipment. When a fault occurs, the high fault current can cause conductors to overheat rapidly, potentially damaging the insulation and leading to further faults. By limiting the peak fault current, CLOPs reduce the amount of heat generated in the conductors, minimizing the risk of damage. Secondly, CLOPs reduce the mechanical stress on electrical equipment. The high fault current can also create strong magnetic fields that exert mechanical forces on conductors and equipment. These forces can damage the equipment and even cause it to fail. By limiting the peak fault current, CLOPs reduce the mechanical forces on the equipment, minimizing the risk of damage. Thirdly, CLOPs reduce the arc flash hazard. An arc flash is a dangerous electrical explosion that can occur when a fault current creates an arc in the air. The arc flash can generate intense heat, pressure, and light, which can cause severe burns, injuries, and even death. By limiting the peak fault current, CLOPs reduce the energy released in the arc flash, minimizing the risk of injury. Now let's turn our attention to series-rated circuit breakers. As mentioned earlier, series rating is a method of coordinating the interrupting ratings of multiple circuit breakers in series. This is necessary when the available fault current at the point of installation of a circuit breaker exceeds its interrupting rating. The interrupting rating of a circuit breaker is the maximum fault current the circuit breaker can safely interrupt without being damaged. Circuit breakers are designed to interrupt fault currents by opening their contacts and creating an air gap that extinguishes the arc. However, if the fault current is too high, the arc may not be extinguished properly, and the circuit breaker may be damaged or even explode. To ensure that circuit breakers can safely interrupt fault currents, they are tested and rated according to industry standards. These standards specify the maximum fault current that the circuit breaker can interrupt under various conditions. When applying series rating, it is important to understand the concept of let-through current. The let-through current is the amount of fault current that the upstream circuit breaker allows to flow through to the downstream circuit breaker. The let-through current depends on the characteristics of the upstream circuit breaker, such as its interrupting rating and its current limiting capabilities. The downstream circuit breaker must have an interrupting rating that is greater than or equal to the let-through current of the upstream circuit breaker. This ensures that the downstream circuit breaker can safely interrupt the fault current without being damaged. To determine the let-through current of an upstream circuit breaker, manufacturers provide let-through curves. These curves show the let-through current as a function of the available fault current. The let-through curves can be used to select the appropriate downstream circuit breaker for a series-rated system. In addition to the interrupting ratings and let-through currents, it is also important to consider the time current characteristics of the circuit breakers when applying series rating. The time current characteristic is a graph that shows the time it takes for a circuit breaker to trip at different levels of fault current. The time current characteristics of the circuit breakers must be coordinated to ensure that the downstream circuit breaker trips before the upstream circuit breaker. This minimizes the disruption to other circuits and ensures that the fault is cleared as quickly as possible. The NEC requires that series-rated combinations of circuit breakers be tested and labeled as such. This ensures that the series-rated combination has been verified to perform as intended. The testing must be performed by a qualified testing laboratory, and the labeling must clearly indicate the series rating and the specific circuit breakers that are included in the series-rated combination. Now, let's consider a practical example of how current-limiting overcurrent protective devices and series-rated circuit breakers are used in an electrical system. Imagine a large commercial building with a main service entrance and several distribution panels. The main service entrance is protected by a main circuit breaker with a high interrupting rating. The distribution panels are fed by feeders from the main service entrance. The feeders are protected by circuit breakers in the main service entrance. The branch circuits in the distribution panels are protected by circuit breakers in the distribution panels. In this system, current-limiting overcurrent protective devices could be used to protect sensitive equipment, such as computers and electronic devices, from the effects of fault currents. The clocks would be installed in the branch circuits that feed the sensitive equipment. Series-rated circuit breakers could be used to coordinate the interrupting ratings of the circuit breakers in the main service entrance and the distribution panels. This would ensure that the circuit breakers can safely interrupt fault currents throughout the system. For example, if the available fault current at a distribution panel exceeds the interrupting rating of the circuit breakers in the distribution panel, a series-rated combination of circuit breakers could be used. The upstream circuit breaker in the main service entrance would have a higher interrupting rating than the downstream circuit breakers in the distribution panel. The let-through current of the upstream circuit breaker would be less than or equal to the interrupting rating of the downstream circuit breakers. This would ensure that the downstream circuit breakers can safely interrupt fault currents without being damaged. In conclusion, current-limiting overcurrent protective devices and series-rated circuit breakers are essential components of electrical systems that provide overcurrent protection. Clocks are designed to rapidly interrupt fault currents and limit the peak fault current, while series-rated circuit breakers are used to coordinate the interrupting ratings of multiple circuit breakers in series. By understanding the characteristics and applications of these devices, it is possible to design and install electrical systems that are safe, reliable, and efficient. Finally, remember to always consult the NEC and other applicable standards and guidelines when selecting, applying, and coordinating overcurrent protection devices. This will ensure that the electrical system meets all applicable requirements and is properly protected from the hazards of overcurrents.